Welcome. Today, we are diving into the world of web application security with Openshift Container Platform, a powerful tool developed by Red Hat. OCP simplifies the process of securing your web applications, making it a go-to solution for developers and administrators alike. Before we delve into OpenShift's security features, let's quickly touch upon OWASP, the Open Web Application Security Project. OWASP is a leading authority on web application security, highlighting common risks through its top 10 list. One critical risk is broken access control, which OpenShift addresses seamlessly. Our focus today is on a key security measure called HTTP Strict Transport Security, or HSTS for short. Imagine HSTS as a safeguard that ensures all communication with a web service is encrypted, shielding sensitive data from prying eyes. What sets OpenShift apart is its simplicity in configuring HSTS headers. Unlike manual setups that can be complex and time-consuming, OpenShift automates this process, empowering developers to focus on coding rather than intricate security configurations. Let's see this in action. I'm using OpenShift Developer Sandbox to deploy a sample Spring Boot application. With OpenShift's source-to-image S2I feature, deploying and securing our application is a breeze. First, we'll deploy the service on OCP using S2I. It's a feature of OpenShift where you provide a source code to OpenShift, and OpenShift will do the rest to download the code, build, and deploy it on OpenShift. While deploying, we'll request OpenShift to create a default secure route for us. The deployment will take some time to complete, so we'll give it a minute and it should be done. So this is a sample code that I have developed. So let me quickly grab the source for it. It's uploaded on Git. We'll go ahead in OpenShift console. In the developer mode, we'll go and click on add, import from Git, and we'll paste the Git URL that we just copied. And OpenShift will go ahead. The S2I process has kicked in. It has found out that it uses Open Java and it suggests to use the OpenJDK 17 runtime. So just for demonstration purpose, we are going to select a different runtime. So let's go ahead and different a lower Java version, Java 11. And we'll select the resource type as deployment config. Okay, that's a standard deployment. And here we are asking TLS termination and insecure traffic to redirect. So this will redirect any HTTP calls to HTTPS. All right, so we'll click the create button and OpenShift will do its magic. It is going to download the source code from Git, compile it, build it, and deploy it on OpenShift. So we can see the process here. Build has been triggered. As you can see, it is building. You can click on see the logs, and here we go. So Maven build has started. So we'll just give it a couple of minutes, and then we'll come back once the deployment is done. All right, it's been a couple of minutes. So our build is completed. So let's go back and let's review the route, which is OpenShift's exposed endpoint for this service. So as you can see, it has created a secure route, but let's go ahead and copy it. But instead of HTTPS, let's go ahead and verify the HTTP route. So what we are going to do is we are going to access the HTTP route. And as you can see, it is HTTP redirect, and it is redirecting it to the HTTP. We can also see that in action in the browser where it actually follows the redirection. So let's go ahead and paste HTTP. And as you can see, it has switched to HTTPS, although we gave it an HTTP because browser is able to follow the redirection. So fine. Now let's go ahead and configure OpenShift route to emit the HSTS header, right? So for that, we will add some annotations. So let's go ahead and open the route. So we'll go into the administrator mode, networking, routes, and this is the route that we created. And we're going to add a annotation. So we'll click on that and we are going to add more, right? So we add the annotation haproxy.router.openshift.io/HSTS underscore header with the parameters like max age is equal to 315.36300. Include subdomains and preload for enhanced security. The max age parameter sets the duration of the HSTS policy. Include subdomains extends the policy to subdomains, and preload enables the preloading in browsers for added security. All right. So now that our route has been configured, so let's go ahead and test it out. So we'll go back and pick up this route again. So let's copy this and let's quickly open the terminal and we'll do the similar thing. We'll do a curl again and this time on HTTPS endpoint. So we're going to hit it and there you see. So we have the stick transport uh, header added to the response, right? So as you can see, OpenShift's integrated security features makes it a game changer for securing web applications. Explore OpenShift today to experience simplified yet robust web application security. Thanks for watching.